All right, guys. So one of the things we want to do is go over elimination again. Kind of talk about why elimination is easier than um, substitution if it works. Okay, I'm gonna preface that with if it works, and we'll talk about a couple of other things. All right, what do we want for elimination? Okay, elimination. We know. Let's label it elimination and substitution. Okay, elimination is going to get rid of stuff, and that's going to make simplified equations. When I substitute, it's going to get a little bit longer, right? So I'm going to do number one two different ways. I'm going to do it by elimination. I'm going to do it by substitution. Okay. When I am doing elimination, I want this. I want it to look like this one looks. And the key is I need the coefficients of one of my variables to be the same, one positive, one negative, right? So I need it to be the exact same number, but I need it to be one positive, one negative. What that does is now that means when I'm solving this, if I add these together, this will go away. Use the other side of my stylus. Because negative 2 plus 2 is 0. So negative 2y plus 2y is 0. So that goes away. So now I just have x plus 3x. That becomes 4x, right? Because this is a coefficient of 1. Always label your coefficients. And then we have negative 2 plus 10 is 8. So that makes it a one-step equation. So I divide that by 4, divide that by 4, and that goes away, right? So now I know what x is. X is 2. Okay? On substitution, substitution might require a little bit more work. Let's do this a different way. Let's do 3x plus 2y. I'm going to put this one on top equals 10 because if I was trying to solve one of these two equations for one variable, which is what we did on substitution, I would solve for this x because it has a coefficient of 1 already. It's positive and it's 1. So this is what we want, right? Again, that's what we talked about in that time. So we got x minus 2y equals negative 2. So to solve this, I would add 2y to both sides. This is now 0, and I have x equals 2y, which is positive, and then negative 2. Now I have what I want. I have x equals some number. We're going to plug that in for this x in the other equation, right? So to plug that in, now I do 3 times 2y minus 2. I still have the plus 2y, and I still have equals 10. Notice how when we did substitution, we had to do a step, and now we got a longer equation. It didn't become a short equation like this 4x equals 8. It became a longer equation. So this one would take some solving. 3 times 2 is 6y. 3 times negative 2 is negative 6. Okay, then we still have the plus 2y, and we have the 10. All right, I want to move the whole numbers to the right. I want to keep the y's on the left. So I will add 6 here, add 6. This goes away. And I have 6y plus 2y, which is 8y. And that equals 16. When I divide by 8, that cancels, and y equals 2. On both of these, we got to go back in and plug in. Oh, sorry, my face is in the way. Make this a little bit smaller. Yeah, so 8y equals 16. Divide by 8, I get y equals 2. All right, I only did half of the problem there, but we got y equals 2. I guess on this side, I go ahead and plug in this 2 in for x. Put it in right there. And so that would give me 2 minus 2y equals negative 2. All right, if I subtract 2, that gives me negative 2y equals negative 4. And then if I divide by negative 2, I kind of ran out of space there, but if I divide both sides by negative 2, I get y equals positive 2. So no matter what, I got the same answer, but this involved a lot more steps right there, right? Many more steps in there than on this side where it immediately got x and then just plugged in and got y. Over here, I had to do this. Now I would still have to plug the 2 in and then solve and get the other one, right? So we're showing how, like, if it's set up correctly, elimination could be faster, right? Either way, I got the same answer. My answer is 2, 2, right? Okay. Um, after looking at that, so that's number one, I got to look at all of these problems, okay? If I'm looking at 2, 3, and 4, which one is going to be the hardest problem? If I look at 2, 3, and 4, I should know right now which one is the problem that is going to give me the most, uh, is going to require the most steps. If you don't know, let's talk about it. So on 2, is there a variable that will immediately go away? Yes. I have plus 3y and I have negative 3y. So that tells me if I add those up, that part of the equation is going to be gone. That's on number 2. So that's an easy problem. This 3 will go away and I'll have 5 minus 3x. So I'll get 2x equals 12. Right? I'll write the whole thing. Something's wrong with my stylus. Minus 3x. Let me go to the other side, I guess. And this one equals 6. And this one equals 6. So if I'm adding them, like I said, the y's go away. This is 2x equals 12. Very easy. Like that step is done. Look at 4. 4 has a 2x and a negative 2x. Minus 5y equals 15. Plus 10y equals 10. So if I see those 2's are the same but opposite signs, that's going to go away. Now I have 5y equals 25. Again, one step and I got my y. 3, on the other hand, when I look at 3 is the biggest issue. 3 has the biggest problem, right? Because 3x minus 7y equals 74, and x plus 2y equals negative 10. All right, so I'm going to bring up the Desmos calculator to kind of show something here. Okay. So on this right now, I don't have a coefficient that matches. I have a 2 and a 7. I have a 3, and this should be a 1. Okay. Is there anything I can multiply 7 by to get 2? No, it's a fraction. Anything I can multiply 2 by to get 7? Nope, it's a fraction. Can I do 3 to get 1? No. However, I can do 1 to get 3, right? Here's something that I try to show in class, okay? The main idea for this, like with the Desmos calculator, I can cheat and just solve it and get the answer, right? I don't have to try very hard with the Desmos calculator because it's going to tell me everything I need, right? Move this out of the way. So if I graph 3x minus 7y equals 74, and I also graph 1x plus 2y equals negative 10. If I graph them both, I can get the answer. There's my answer. 6, negative 8. Right? That's the answer. But we're trying to solve these algebraically. So when I'm doing that, I want a 3 here. I'm lying. I want a negative 3 there. All right, that's going to be the easiest number. A 1 is easy because I can just multiply by exactly what I want and I get it. So let's just multiply this by negative 3. Negative 3 times 1x is negative 3x. Negative 3 times 2 is negative 6y. Negative 3 times negative 10 is positive 30. Now I have what I want up here with the x. So I just bring the other equation down. Right? And add them up. This part will go away. Now I have negative 6y and negative 7y, so that's negative 13y. And this is just 104. But that's not a, now that's an easy problem. I divide by negative 13, divide by negative 13, and what do I get? I get what I knew I was supposed to get, right? I get this. I get y equals negative 8. Okay? Here's the deal. Why did we have to multiply the negative 3 times all of these? I wanted a negative 3 here with x. Think about this. Here's my answer. Right? What if I just put a negative 3 here because that's what I want? Notice that changed everything. But when I multiply all of these, when I get the negative 3x, the negative 6y, the 30, delete all this. Now I'm back to the exact same answer. What that means is when I multiply by negative 3, this equation and this equation are exactly the same. They're the same equation. We just made it look the way we wanted. That's why we multiply by negative 3. Right? But that should help you. Now we did number 1 and number 3.